Hello everybody, today I'm going to explain the solution to the second problem from the 2025 USACO US Open Contest in the Bronze Division, the problem More Cow Photos. In this problem, we are given an array of length n, and we have several goals we need to fulfill in order to construct a picture of the cows. And we wanted first the sequence to be first increasing and then decreasing, so kind of like a mountain sequence. And for every two consecutive cows in the sequence, they shouldn't be of the same height. And for the third condition, the picture must be symmetric. So basically, kind of like a palindrome sequence. So basically, we have these three conditions, and we want the picture to contain as many cows as possible. And specifically, like we are told here, the farmer John can remove some of the cows and rearrange the remaining ones in order to satisfy the constraints. And here we have a relatively big array, and the numbers are from 1 to n. So because we are allowed to rearrange the values as we want, this gives us the intuition to use frequency arrays. So frequency arrays have been a recurring theme during this season, with at least one problem in every contest of this season featuring frequency arrays. Maybe I will make actually a video on frequency arrays since they seem to have been showing up a lot as of late. And when it comes to, let's say, rearranging them, we want to have basically a cow in the middle, and then this cow must be surrounded by cows on the side in such a way that we have counterparts for every single type of cows. So if we try to express this more mathematically, let's say that we have a value x1 in the middle, and this value must be surrounded by equal values. So x2, x3, x4, and so on. And basically, if we were to rephrase the conditions, x1 must be greater than x2, must be greater than x3, greater than x4, and so on. And also, because of these conditions, the frequency of x1 must be greater or equal than 1. The frequencies for x2 must be greater or equal than 2. The frequency of x3 must be greater or equal than 2, and so on. Now, a very simple solution we can come up with is to have a for loop where we fix the position of the greatest value. Let's say that we fix it to be equal to 7. And we can now count how many integers smaller than 7 show up at least twice in the array. Because if, for example, we have the integers 3, 5, and 6 showing up at least twice, we can rearrange the array in something like 3, 5, 6, 7, 6, 5, 3. So basically, we can have this sort of rearrangement and it fulfills the conditions. But given that n is up to 100,000, we actually would have an n-squared algorithm if we just iterate over these maximum values and repeat the process every time. So now what we want to do is to use these properties here to actually traverse the array, or more like the frequency array, from 1 to n. And basically the reason why we want to do this is because for a given number, we want to basically have track of how many numbers smaller than it have a frequency of at least 2. Because this number of integers smaller than 2 in frequency can be placed in a convenient way around the middle value we choose. And therefore, if we fix the middle value, which has a frequency of at least 1, we would already have information of how many integers show up at least twice in the array. And this can actually be done using just a simple for loop, which runs in linear time. And we don't even have to have any sort of nested for loop. And as you saw here in this image, it was actually the first problem I tried. And after reading through all of them, I coded this very quickly, as you will see in the coming seconds. So as you see here, I first found the frequencies of each value. I just read the input and found the frequencies. And then for every single integer from 1 to n, obviously the initial answer must be at least 1, because no matter what we do, we can place something in the middle. And if the frequency is at least 0, so at least 1, it shows up at least once, then we keep track of this count, which tells us how many times we found a frequency of at least 2. Because this count will tell us how many layers of integers we can place around the middle. And this is why here we have the maximum between whatever answer we got and count times 2 plus 1. And here I increment the count if and only if this frequency is at least 2. So it's a bit of a short way to write the if statement, but basically it's equivalent to something like if frequency is at least 2, you increment the count. And as you see, this code is very short. After reading the inputs, it's only a matter of 10 lines or so. And it uses an idea which has been emphasized over and over this season. Every contest had a frequency array problem this season in bronze, and it's a very powerful idea and tool to use. So to conclude, we want to use frequency arrays in order to use the conditions from the problem to simplify our implementation. If you enjoyed watching this video, please like the video, subscribe to the channel, and press the bell button in order to stay notified as I upload more interesting things over the break before the next USACO season, and also other educational videos I have in plan, be it for other algorithms, data structures, or other USACO problems, or who knows, maybe if I have the time, other contests as well on Codeforces or on other platforms. Also, if you or someone you know is interested in working more closely with me, please check out the links in the description in order to join my tutoring program, which helped over 20 students achieve promotions to higher divisions this season. Until the next time, good luck with your summer preparation, and I'll see you next time. Cheers!